Right, as always, I hope things are going fantastically well for you wherever you are. My name is Dr. Jason Dinsmore, aka the OChem Whisperer, and I want to help you succeed in your organic chemistry class. Now, what we're going to be specifically working on in this session is we're going to be looking at carbonyl compounds. And specifically, if you look at this question, typically what you're going to have is you're going to have your starting material, you're going to have your reagents above and or below the reaction arrow, and then you're going to have to predict the product. What we're going to do is go in the reverse direction. So what we want to be able to do is figure out we've got our product, we have our reagents, but what is going to be our starting material, okay? And in this case, we're going to be specifically focusing on carbonyls. So if we look at this, the way that we're going to approach this question is what I first want you to do is locate your Grignard, because that's what's going to come in and attack. And the other thing that I want you to focus in on is where is the carbon that has your OH, okay? So what I'm going to do here is I'm going to go ahead and copy this. I'm going to bring this just up here so we can look at it, okay? So this is going to be our main point. What we want to do is focus in on this point right here. What we also want to remember the fact is that there's a hydrogen on here that we don't write, but we want to pay attention to that because that's going to be helpful in going backwards, okay? So if we think about this, we know the fact that we have to start with a carbonyl, and now we're going to the alcohol. So that means that we've added something, and that's where the Grignard's going to come in. So we're going to notice we have a CH3 group right here. What you want to do is go to your final product and look to see where that same part of your Grignard is. We're going to notice it's right here, right? So that's the group that got added in. Okay, so what I'm actually going to do here is I'm going to go ahead and write CH3, and that's the bond. So now we know to go backwards, what we're going to have to do is go ahead and remove that. So what we basically want to take is the CH3 and this bond away. Okay, so watch this. I'm going to do it right here. So I'm going to grab this, and I'm going to take this whole thing off. Okay, so let's imagine we just erase that. So if we did that, we know that there's a CH3. It's not a CH3 line. We know specifically that it's a CH3, then it would be a negative charge because we have to bring the electrons with us. That's what the Grignard means. So now what does that mean? That means that right here, if we just kind of go backwards, that has to have a plus charge, right? Because we only have 3 bonds to carbon now, not 4. So now in order to go back to the carbonyl, we also have to look at something else. Let's go ahead and grab gray. This hydrogen right here, that came from this H2O right there. So that was not initially on our carbonyl. So not only was the carbon not initially on our carbonyl, because we had to pull that off, we're also going to pull off the H, okay? So we're going to pull that H off. Now we want to remember that in this case the carbonyl attacked the H didn't attack the carbonyl. The Grignard is negatively charged, but the H is positively charged. So what does that mean? That means our oxygen was negatively charged. So if we look at this, it's our Grignard that came in and attacked, and then it's our oxygen that came in and attacked. So now if we look at this, we've got a plus and a minus side by side. All we need to do is basically bring those together. So if you have a plus and a minus side by side, that's basically a bond. So if we were just to bring this negative charge down like that, check this out. What does that give us? That gives us a carbonyl. And what do we have over here? We have that blue H that I didn't carry along, so I should have put that down here. Now what we do is if we go over here, check that out. We have that H, and we've just solved, whoops, I meant to copy this. Whoops, let's not grab the box. We've just solved the question right there by going backwards, right? It's really that simple. Now what I want to show you here is, this is going to be a little messy, but let me see if I can bring it up. Sweet, look at that. So what we're going to do here is, that's how to go to the Grignard. Let's say your professor posed it this way. Actually, let's even make it even easier. Let's go ahead and delete all this. Let's delete all this. And let's say your professor said, given this molecule, go ahead and tell me what Grignard and what carbonyl you started with, okay? Now the thing here is, and I'm going to draw the H in here, there's really going to be 3 options. So if we look at this, what we want to do is we want to look at each group coming off of there, and we're going to break it apart, okay? So if we look at this, what can we do? On this one, we can remove the CH3 group. And as we saw, we've already done that. I could do CH3, MgBr, that's going to be 1, and then we're going to keep all the rest. So that's going to be a carbonyl with its carbon structure, and then that's going to be an aldehyde. Okay? What about the middle one? So we'll just track this along. Now, what happens if we take the H off? So what that's going to do is that's going to give us a carbonyl. We're going to have all the carbon there, but where that hydrogen is going to come from is, let's say, lithium aluminum hydride. That's going to be our source. Not a Grignard, but our nucleophilic source is going to be an H-. Okay? You see where this is going? It's really easy, right? Our point that we want to focus in on is this carbon with the oxygen, because that's always going to house or have our carbonyl. We're always going to make a carbonyl. We have to pluck something off. Now the last one, I know you all are going to be rock stars on this one. We're basically going to keep this. We're going to put our H on this side now. And then our Grignard is going to be this carbon. How many do we have? 3. So let's do Br, Mg, and then 1, 2, 3. So those right there, if you look at that, those are our 3 options of carbonyls that we can go back, plus let's say nucleophiles, Grignards in 2 cases, but hydride in another. Those are the 3 options where we can go backwards, all right?